Good morning, children. So, in today's class, we will discuss some of the left exercise question of chapter Atoms and Molecules. So, we will first solve question number 11. That is your exercise question of chapter 3. Here, calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. Okay, so here we have to calculate number of aluminium ions present in 0.051 gram of aluminium oxide. So for that we should first know what is the chemical formula of aluminium oxide. Okay, so here as a hint, you have been given the atomic mass of aluminium, that is 27U, and you must also know that mass of atom is equal to mass of ion. Okay, so if you see the chemical formula of aluminium oxide, it is Al2O3. Okay, so first we should know how many aluminium ions are present in aluminium oxide, because we have to calculate number of aluminium ions in 0.051 gram of aluminium oxide. So first we will calculate that 1 mole of aluminium oxide contains how many aluminium ions in it. Okay, so if you see the chemical formula of aluminium oxide, it is Al2O3, and by seeing the chemical formula we could say that there are 2 aluminium ions. This is the aluminium ion Al3 plus, and there are 2 aluminium ions present in aluminium oxide, and there are 3 oxygen ions present in aluminium oxide. So basically aluminium oxide is made up of 2 aluminium ions and 3 oxygen ions. We should pay attention to aluminium ions because we have to calculate number of aluminium ions. Okay, so now we will calculate first the molar mass of aluminium oxide. Okay, so molecular mass of aluminium oxide is equal to 2 into atomic mass of aluminium, that is 27U, plus 3 into atomic mass of oxygen, that is 16U. So 102U molecular mass. So molar mass of Al2O3 will be 102 gram, which is mass of 1 mole of Al2O3. Okay, so aluminium oxide, 1 mole of aluminium oxide, which is equal to 102 gram, okay, contains 2 aluminium ions. Okay, so if you see the molar mass of aluminium or aluminium ions, as I have told you that mass of the atom will be equal to the mass of ions. You know, mass of atom is equal to mass of ions. So the molar mass of aluminium will be equivalent to the mass of aluminium ion. So if you see the molar mass of aluminium, it is equal to 27 gram. Okay, since there are 2 aluminium ions, so we will multiply it with 2 into 27, multiply it with 2, and we will get here how much? 54 gram. Okay, and 54 gram is equivalent to how many moles? 2 moles of aluminium or aluminium ions. Okay, so from that we have got that 102 gram or 1 mole of aluminium oxide contains 2 moles of aluminium ions. So this we will just write it here. 1 mole of aluminium oxide contains 2 moles of aluminium ions. Okay, so 1 mole of aluminium oxide can be written as 102 gram of aluminium oxide contains 2 moles of aluminium ions. Now we know that 1 mole of anything, so here 1 mole of aluminium ions will be equal to how many ions? What are the number of ions? Avogadro number of ions, that is 6.022 into 10 to power 23 aluminium ions. Okay, 1 mole of aluminium ions is equal to 6.022 into 10 to power 23 aluminium ions. So 2 moles of aluminium ions will be equal to 2 into 6.022 into 10 to power 23 aluminium ions. So this value we will put it in place of 2 moles of aluminium ions. So the same sentence can be written as 102 gram of aluminium oxide contains, in place of 2 moles of aluminium ions we will write 2 into 6.022 into 10 to power 23 aluminium ions. Now what is asking in the question? To calculate number of aluminium ions in 0.051 gram of aluminium oxide. So we are knowing the number of aluminium ions in 102 grams of aluminium oxide. We have to calculate in 0.051 gram of aluminium oxide contains how many number of ions. So we will write here, so 0.051 gram of aluminium oxide contains, we'll apply the unitary method, 0.051 into 2 into 6.022 into 10 to power 23 aluminium ions divided by, here we'll write gram, divided by 102 gram. Okay, so we will get here 0.0, we'll simplify and get 0.00602 into 10 to power 23 aluminium ions, which can be written as, if we shift the point after 3 values, we can write here 6.022 into 10 to power, it becomes how much? 20 aluminium ions. Okay, so this will be your answer. So 0.051 gram of aluminium oxide contains 6.022 into 10 to power 20 aluminium ions. So this is the simplest method you can use to calculate or to solve this question. I will repeat again. Here you have to first find out the molar mass of aluminium oxide. Molar mass will give you the mass of 1 mole of aluminium oxide, and you have to also see by writing the chemical formula of aluminium oxide that how many number of aluminium ions are present, or how many aluminium ions make the aluminium oxide molecule. So when we write the chemical formula, we can just predict how many aluminium ions are present here in aluminium oxide. So there are 2 aluminium ions and 3 oxygen ions which make up the aluminium oxide. Since we have to calculate number of aluminium ions here, so we will just take into consideration the aluminum ions only. So here we can see 100 gram we have got the molar mass of aluminum oxide, or mass of 1 mole of aluminum oxide. It contains 2 aluminum ions. So if we calculate the molar mass of aluminum ion, it is same as the mass of aluminum atom, that is 27 gram. Since there are 2 aluminum ions, so we will multiply it with 2 and we will get 54 grams. So 1 mole of, or 102 gram of aluminum oxide contains 54 gram of aluminum ions. When we convert it into moles, we will see that 54 gram is nothing but 2 moles of aluminum ions. So we can say, now we can also say that 1 mole of aluminum oxide contains 2 moles of aluminum ions. So that the thing we have written here, 1 mole of aluminum oxide contains 2 moles of aluminum ions. And 2 moles of aluminum ion can be written as 2 into 6.022 into 10 to the power 23 aluminum ions. And 1 mole can be written as 102 gram of aluminum oxide. So we can write it as 102 gram of aluminum oxide contains, in place of 2 moles I have written 2 into 6.022 into 10 to the power 23 aluminum ions. So we will calculate in 0.051 gram of aluminum oxide contains how many aluminum ions. We will apply the unitary method and we will get, after calculation, we will get the value 6.022 into 10 to the power 20 aluminum ions, which are present in 0.051 gram of aluminum oxide. Okay. Next question is, in aqueous solution, magnesium chloride dissociates into ions as follows. Here dissociates means breaks down. Okay, breaks down into ions. Okay. So when magnesium chloride, it is written here AQ. AQ represents the aqueous. Aqueous means MgCl2 is dissolved in water. Okay, so MgCl2 aqueous means it is in the form of solution in water. So when MgCl2 is dissolved in water, or it makes the solution in water, it dissociates into magnesium ions and chloride ions. Okay, so here calculate the number of ions produced when 23.75 gram of magnesium chloride is dissolved in water. Okay, so here in the question is asking to calculate number of ions. So number of ions means it is asking total number of magnesium ions and chloride ion present in MgCl2 solution. Means when it is dissolved in water, then the total number of magnesium and chloride ion produced, that we have to calculate, and then we have to calculate the total number of ions in 23.75 gram of magnesium chloride when it is dissolved in water. Okay, so as you have studied before in your class 8, that the salt in aqueous solution dissociates into its constituent ion. So here also the same thing is happening when MgCl2, which is a salt, when it dissolves in water or when it forms the aqueous solution, then it dissociates itself into its constituent ions, that is magnesium ions and chloride ions. Okay, so here first we have to calculate the molar mass of MgCl2. So if we calculate the molar mass of MgCl2, it is about 95 gram. So we will write the reaction again here. MgCl2 aqueous, on dissociation it gives Mg2 plus aqueous and 2Cl minus aqueous. Mg2 plus aqueous shows that the ions which is produced, they still are in solution only, in aqueous. That is why it is written aqueous. It is the ions which are produced, they are not separated but they are in the solution itself. Okay, so if you see the molar mass, it is 95 gram. So 95 gram of MgCl2 on dissociation gives, as I told you, that mass of atoms is equivalent to mass of the ions. So what would be the molar mass of magnesium atom will be the mass of magnesium ions also. So it is, if you see the molar mass of magnesium, how much it is? It is about 24 grams. So the mass of magnesium ion is also 24 grams. And if you see the, here there are two Cl minus, means two chloride ions are produced. So 2 into molar mass of chlorine atom will be equivalent to its 2 into molar mass of chloride ions. So it is 35.5 gram, which we get here 71 gram. So if you see the moles here, 24 grams is equivalent to 1 mole of magnesium. 1 mole of magnesium, or you can say magnesium ions. Okay, and here 71 gram, if you see, it is 2 moles of chlorine. 71 gram, if you calculate, it comes 2 moles of chlorine or chlorine ions. Okay, and 95 gram is the molar mass of MgCl2. That means it is the mass of 1 mole of MgCl2. So from this we have got one equation, that 1 mole of MgCl2 contains 1 mole of magnesium and 2 moles of magnesium ions and 2 moles of chloride ions. So total 1 mole of magnesium chloride contains 3 moles of magnesium and chloride ions. We will write it separately here. So here we can write that 1 mole of MgCl2 contains 1 mole of magnesium ions plus 2 moles of chloride ions. Okay, like that we can write. And we can also write here 1 mole is equivalent to 95 grams. So we can just write here, or we can just write 1 mole only here. We'll write 1 mole of magnesium chloride contains, instead of 1 mole of magnesium ion, we can write the number of atoms, because we have to calculate number of ions. So we can write the 1 mole of magnesium ion contains how many number of ions? It contains Avogadro number of ions. So we can write Avogadro number of magnesium ions plus, here 2 moles of chloride ions means 2 into Avogadro number of chloride ions. Okay, so it will be equal to 1 mole of magnesium chloride will be equal to Avogadro number of magnesium ions means 6.022 into 10 to power 23 ions plus 2 into Avogadro number of chloride ions means again 6.022 into 10 to power 23 ions. So here we can just take common 6.022 into 10 to power 23 to solve. So we'll just take common here 6.022 into 10 to power 23. We'll just take common this and this. So we will get 1 plus 2. Okay, here ions. Okay. Is equal to, we will get 6.022 into 10 to power 23 into 3, which is equal to, you can just write into 3, which will be equal to 18.066 into 10 to power 23 ions. So 1 mole of magnesium chloride contains total of 18.066 into 10 to power 23 ions. Okay, so we can write just this sentence as here: 1 mole of MgCl2 is equal to 18.066 into 10 to power 23 ions we have got. Okay, 1 mole of magnesium chloride contains total number of ions, how much? 18.066 into 10 to power 23 ions. Now it is asking number of ions produced when 23.75 gram of magnesium chloride is dissolved in water. So 1 mole of magnesium chloride is nothing but how much? 95 gram of magnesium chloride is equal to 18.066 into 10 to power 23 ions. We can just write this one like this only. Instead of 1 mole I have written 95 gram. Now we have to calculate in 23.75 gram of magnesium chloride will be equal to, will apply the unitary method, is equal to 23.75 gram into 18.066 into 10 to power 23 ions divided by 95 grams. If you solve this one, then you will get around 4.5 into 10 to power 23 ions totally. So this will be your answer. So 23.75 gram of magnesium chloride contains total of 4.5 into 10 to power 23 ions. Okay, so here I'll repeat what we have done. First we have calculated the molar mass of MgCl2, molar mass of magnesium ions, and molar mass of chlorine ion. Okay, chloride ions. How we have calculated molar mass of magnesium ion? Molar mass of magnesium atom will be equal to its ion. So it's nothing but 24 gram, and for chlorine also it is 35.5 gram. And since there are 2 ions of chlorine, chloride ions are there, so we have just multiplied with 2 and we have got 71 gram. So if we see the MgCl2 molar mass is 95 gram, it contains 24 grams of magnesium ions and 71 grams of chloride ions. So 24 gram, if we calculate into moles, it comes 1 mole of magnesium ions, and 71 gram of chloride ion also we will, if we convert it into moles, it comes around 2 moles of chloride ions. Since we can just write it as 1 mole of magnesium chloride contains 1 mole of magnesium ions and 2 moles of chloride ions. So total we can just write it as 1 mole of magnesium chloride contains 1 mole of magnesium ions plus 2 moles of chloride ions. Why I have written plus here? Because we have to calculate total number of ions here. That is total number of magnesium ions and total number of chloride ions. So we have to add up both the number of ions, that is total number of magnesium and total number of chloride ions. So the same sentence we can write it as 1 mole of magnesium chloride contains, instead of 1 mole of magnesium I have written the Avogadro number of magnesium, and since we have to calculate number of ions, so I have just converted 1 mole of magnesium ion into Avogadro number. You know, 1 mole of anything contains Avogadro number, so of particles. So I have written, in place of 1 mole of magnesium ion, I have written Avogadro number of magnesium ions, plus 2 moles of chloride ion means 2 into Avogadro number of chloride ions. Okay, so we will just put the value of Avogadro number 6.022 into 10 to power 23 ions plus 2 into 6.022 into 10 to power 23 ions. We will take the Avogadro number as common, and when we will solve it, we will get 18.066 into 10 to the power 23 ions. Means 1 mole of magnesium chloride contains 18.066 into 10 to the power 23 ions. So 1 mole can be written as 95 grams of magnesium chloride contains 18.066 into 10 to the power 23 ions. So we have to calculate in 23.75 gram of magnesium chloride. What would be the ions, number of ions? So we will apply the unitary method and we will get 4.5 into 10 to the power 23 ions. So that's how you can solve this question.